Hello, here we are again after a couple of weeks off, and we will continue with the physical layer part 2. For those who are new at this channel, please do not forget to subscribe, and let's continue. After we saw the purpose of the physical layer and her characteristics, we will continue with copper cabling and UTP cabling. The copper cabling is the most common type of cabling used in networks today. In fact, it's not used only one type of cable. There are 3 different types of copper cabling that are each used in specific situations. And networks use copper media because it is inexpensive, easy to install, and has the low resistance to electrical current. However, the copper media is limited by the distance and the signal interference. Data is transmitted on copper cables as electrical pulses. A detector in the network interface of destination device must receive a signal that can be successfully decoded to match the signal sent. However, the further the signal travels, the more it deteriorates. This is referred to as a signal attenuation. For this reason, all copper media must follow strict distance limitation as specified by the guiding standards. The timing and the voltage values of the electrical pulses are also susceptible to interference from 2 sources. The first one is the electromagnetic interference or radio frequency interference, as called particularly as EMI or RFI, and those signals can distort and corrupt the data signals being carried by copper media. And the second one is the crosstalk, where is a disturbance caused by the electrical or magnetic field of a signal on one wire to the signal in an adjacent wire. And as it can be shown in the figure, there is how data transmission can be affected by the interference. In the first one, there is a pure digital signal that is transmitted, and in the second one, on the medium, there is even an interference signal. And in the third one, you can see that the digital signal is corrupted by the interface signal. And at the fourth graph, you will see that the receiving computer reads a change signal. You will see that a 0 bit is now represented as a bit 1. To counter the negative effects of EMI and RFI, some types of copper cables are wrapped in metal shields and require proper grounding connections. To counter the negative effects of crosstalk, some type of copper cables have opposing circuits wire pair twisted together, which effectively cancel the crosstalk. The susceptibility of copper cables to electronic noise can be also limited by using this recommendation: selecting the cable type or category most suited to a given networking environment. You can design a cable infrastructure to avoid known and potential source of interface in the building structure, or by using cabling techniques that include the proper handling and termination of the cables. As we said before, there were 3 main types of copper media used in networking, and those are unshielded twisted pair, UTP cable, shielded twisted pair, STP cable, and the coaxial cable. We will see each of those in the next slides. The unshielded twisted pair, or as we will call that as UTP cabling, is the most common networking media. It is terminated with RJ45 connectors and is used for interconnecting network hosts with intermediary networking devices such as switches and routers. In LAN, the UTP cable consists of 4 pairs of colored coated wires that have been twisted together and then encased in a flexible plastic sheath that protects them from minor physical damage. The twisting of wires help protect against signal interference from other wires. And as you can see in the figure, the color codes identify the individual pair and wires and aids in cable termination. So you can see that the figures that with one, we have been selected to show you that the outer jacket protects the copper wire from physical damage. And with the number 2, you can see that there are twisted pairs protect the signal from the interface. And with the number 3, we have shown that the color-coded plastic insulation electrically isolates wire from each other and identifies each pair. The shielded twisted pair, or as we will call STP cables, provide better noise protection than UTP cabling. However, compared to UTP cables, STP cable is significantly more expensive and difficult to install, and they use the same RJ45 connectors. STP cables combine the technique of shielding to counter the electromagnetic interface and radio frequency interface and wire twisting to counter crosstalk. To gain the full benefit of shielding, STP cables are terminated with special shielded STP data connectors. If the cable is improperly grounded, the shield may act as an antenna and pick up unwanted signals. The STP cable shown in the figure will 4 pairs of wires, each wrapped in a foil shielded, with which are then wrapped in overall metrical braid or foil. And as you can see in the figure, there is the outer jacket that will protect them from the physical damage. And number 2, the braided or foil shield, and the number 3, foil shields, are for protecting them. So much better protection from the electromagnetic interface and radio frequency interface. And at the 4th one, you can see the twisted pairs that are for protecting them from crosstalks. The coaxial cable, or as we will say in the future, the coax for short, gets its name from the fact that there are 2 conductors that share the same axis. And the coaxial cable consists of the following: where is a copper conductor that is used to transmit the electronic signals. A layer of flexible plastic insulation surrounds a copper conductor, and the insulating material is surrounded in a woven copper braided or metallic foil that acts as the second wire in the circuit and as a shield for the inner conductor. This second layer or shield also reduces the amount of outside electromagnetic interference. The entire cable is covered with a cable jacket to prevent the minor physical damage. And there are types of connector used with coaxial cable. They are called as bayonet nail concealment, BNC, and they are type N or F. And also, the UTP cable has essentially replaced the coaxial cable in the modern Ethernet installation. There is still coaxial cable design and is used in the following situation: when we will have the wireless installation, since the coaxial cables will attach antennas to the wireless device, and in case of cable internet installation, since the cable service providers provide internet connectivity to the customer by replacing portion of coaxial cables and supporting amplification element with fiber optic cable. However, the wiring inside the customer's premises is still coaxial cables. And as you can see in the figure, that is shown how the coaxial cable is inside, and you can see the outer jacket, the braided copper shielding, and the plastic insulation and copper conductor, as we explained in the slide before. And as we mentioned, there are 2 different types of connectors, and in the figure you can see that B and C connectors and the N-type and F-type. Because the UTP cabling is the standard for use in LANs, we will go into detail about its advantage and limitation and what can be done to avoid the problems. When used as a network medium, UTP cabling consists of 4 pairs of color-coded copper wires that have been twisted together and then encased in a flexible plastic sheath, as we said that before. Its small size can be advantageous during installation. UTP cables do not use shielding to counter the effects of electromagnetic interface and radio frequency interface. Instead, cable designers have discovered other ways that they can limit the negative effect of crosstalk. The first one is the cancellation. With this, the designers now pair wires in a circuit, and when two wires in an electrical circuit are placed close together, their magnetic fields are the exact opposite of each other. Therefore, the two magnetic fields can cancel each other and also cancel any outside electromagnetic interface and radio frequency interface signals. And the second one is by varying the number of twists per wire pair. So, to further enhance the cancellation effect of paired circuit wires, the designer varies the number of twists of each wire pair in a cable. UTP cable must follow the precise specification governing how many twists or braids are permitted per meter of cable or per 3.28 feet per cable. As you can see in the figure that the orange and orange-white pair is twisted less than the blue and blue-white pair, and each color pair is twisted a different number of times. UTP cables rely slowly on the cancellation effect produced by the twisted pair to limit signal degradation and effectively provide self-shielding for wire pairs within the network media. The elements that define the UTP cabling are as follows: the cable types, cable lengths, connector, cable termination, and the method of testing the cable. The cables in higher categories are designed and constructed to support higher data rates. As new gigabit speed Ethernet technologies are being developed and adopted, the category 5E is now the minimally acceptable cable type, with the category 6 being the recommended type for the new building installation. And as you can see in the figure, there are 3 categories of the UTP cable, where the category 3 was originally used for the voice communication over voice lines, but later used for data transmission. The category 5 and 5E is used for data transmission, and it supports the 100 megabits, and category 5E support 1000 megabits per second. The category 6 has an added separated between each wire pair to support higher speed, and the category 6 support up to 10 gigabit per second. It is not shown, but the category 7 also supports the 10 gigabit per second, but the category 8 is for supporting the 40 gigabit per second. And the UTP cable is usually terminated with an RJ45 connectors, and the standard describes the wire color codes to pin assignment, so the pinouts to the Ethernet cable. And as it is shown in the figure, the RJ45 connector is the male component crimped at the end of the cable, and the socket, where it is shown in the figure, is the male component of a network device wall coaxial perch outlet or patch panel, and when terminated improperly, each cable is a potential source of physical layer performance degradation. The first figure is shown an example of badly terminated UTP cable. This bad connector has wires that are exposed, untwisted, and not entirely covered by the sheath. And in the second figure, you may see that there is a properly terminated UTP cable. It is a good connector with wires that are untwisted only to extent necessary to attach the connector. We have to point out that improper cable termination can impact the transmission performance. Different situations may require UTP cables to be wired according to different wiring conventions. This means that the individual wires in the cable have to be connected in different orders to different sets of pins in the RJ45 connectors. So the main cable types that are obtained by using the specific wiring conventions are the Ethernet straight-through, and this is the most common type of networking cable. It is commonly used to interconnect a host to a switch and a switch to a router. Ethernet crossover is a cable that is used to interconnect similar devices. For example, to connect switch to a switch, a host to a host, or a router to a router. However, crossover cables are now considered a legacy as the network interface cards use medium-dependent interface crossover to automatically detect the cable type and make the internal connection. Another type is the rollover cable, but it's a Cisco proprietary. Using a crossover or a straight-through cable incorrectly between devices may not damage the device, but the connectivity and the communication between those devices will not take place. This is a common error, and checking that the device connections are correct should be the first troubleshooting action if the connectivity is not achieved. And in the figure, we can identify the individual wire pair for the two standards, and at the table there is shown the UTP cable type, related standard, and the typical application of these cables. Thank you for being with me at the second session of physical layer. We will see together at the next one. And for those who haven't been subscribed, please do not forget to subscribe AA Networking, and see you soon.